Alright, welcome back, Math Scholars. Professor McMath here. We're going to be talking about how to solve now a log equation. So we discuss exponential equations, ones you can use, rewrite the bases to solve them, others require logarithms. Now let's talk about log equation. So a logarithmic equation is one that has one or more logs in it. What we're going to use our definition of logarithms to either rewrite it as an exponential, or the property to condense it if there's multiple logs on the same side of the equation. So if we have log base 36 of x equals 32, what we're going to do is we're going to use that exponential logarithm property, the fact that log base a of x equals y, same thing as a to the y equals x. So here we'll rewrite this as 36 to then the 3/2 power equals x. Well, since it was just x and it's all by itself, we just kind of typed it into our calculator and evaluate it. And this becomes 216 is our value for x. Now obviously if this was a little bit more complex, let's say it was like log base 36 of like 2x minus 4, we would start off the same way. We would say 36 to the 3/2 power, but equals 2x minus 4 then. So when it comes out as 216, then we just solve this basic linear equation. Add the 4 to make it 220, divide by the 2 to get x to be 110. Okay, so it all depends on how straightforward it is or what's going on inside the expression itself. So if there's a single logarithm on one side, there's no logs on the other side, we're just going to use our exponential rules to rewrite it as an exponent and then solve it out from there. Now, remember, natural logs are just simply log base e, so the rules for those still apply, and we can solve equations using that. Pretty much the base of the logarithm doesn't really matter too much if we have a log equal to another log. Because what this means is, if they're both the same bases on left and right-hand sides, that means the inside expressions must be equal to each other. X squared minus 15 must equal 2x. Well, if it's x squared, this is a quadratic, so we have to move the 2x over. Make it x squared minus 2x minus 15 equals 0. And, well, now we got a quadratic factor. So we'll set up our two sets of parentheses. We'll have an x minus 5 and an x plus 3 as our two binomial terms, meaning x equals 5 and negative 3. Now, the one thing with these log equations, if you solve out when you have two logs equal to each other like this, you need to always plug answers back in to make sure they make logical sense. So we would have ln of 5 squared minus 15 equals ln of 2 times 5. We get ln of, that jumped ahead. We get ln of 10 equals ln of 10, and that makes sense, we're okay. If we plug in the negative 3 though, we have ln of negative 3 squared minus 15 equals ln of 2 times negative 3. We would get ln of negative 6 equal to ln of negative 6. And while the left and right hand sides have the exact same expression, we cannot take logs of negative numbers or logs of 0. So if you plug back in and find you have a 0 inside for the logarithm or a negative inside for the logarithm, then that means that is not a possibility. Negative 3 does not work mathematically. Our only answer was x equals 5. Now again, just because the insides can't be negative doesn't mean the value of x can't be negative. All we had to do was just simply make that a ln of negative 2x right there, and then a negative x would be perfectly fine. So just always plug in, don't assume positives work and negatives don't. If when you plug in every single answer does not work, then you have no solution. So we have log of negative 2x minus 1 minus log 7 equals log 28. Well, here's where we need to use our rules for condensing. If we're subtracting two logs, we can condense that by division. So this becomes log of negative 2x minus 1 over 7 equals log of 28. So now that we've condensed the left-hand side into a single logarithm, we can now set the inside expressions equal to each other. Negative 2x minus 1 over 7 equals 28. So I multiply both sides by 7 to cancel that out. Well, negative 2x minus 1 equals 196. Add the 1 to get 197. And then when I divide by the negative 2, we will get x equals a negative 98.5 as our decimal form. Again, always should plug back in just to make sure it makes logical sense with the logarithm. So log of -2 times a -98.5 minus 1. And this becomes log, well, negative times a negative is a positive 197, minus 1 is 196. And if we condense that by dividing by 7, you'll get it to be 28, and we're okay. The key really is, though, making sure the inside log is not negative or 0. Assuming your algebra is all solved for correctly in there, you don't make a simple adding or subtracting mistake, or multiplying or dividing or whatever, then you can pretty much trust that once it's log of a positive, you're okay. If you do want to plug in all the way, well, again, we have log of 7. You can actually type both those into your calculator, log 196 minus log 7, to get a number, compared to log 28, and it should be the same number. Your call. Alright, so here we have the left-hand side is log base 3. The right-hand side has no log. Well, we still need to condense this. We don't want to try and move a log expression over to the right-hand side, because that's not going to work. You can't condense and solve a logarithm if you have a number plus another log. But if I'm adding two logs together, I can condense that. We condense addition of logarithms by multiplication. So it becomes x squared plus 2x minus 15 equals 2. Well, since the left-hand side is the logarithm, but the right-hand side is not, we need to use our exponential rule to rewrite this as 3 squared equals x squared plus 2x minus 15. Which means 9 equals x squared plus 2x minus 15. When we subtract the 9, we'll get 0 equals x squared plus 2x minus 24. So when we factor that, we'll have an x plus 6 and an x minus 4. So x equals negative 6 or positive 4. Again, plugging back in, log base 3 of negative 6 minus 3 plus log base 3 of negative 6 plus 5. We'd have log base 3 of a negative 9 plus log base 3 of negative 1. Both those are negative, but again, all it takes is one expression to be negative for that to not actually be an answer. So if we then try log base 3 of 4 minus 3 plus log base 3 of 4 plus 5, we get log base 3 of 1 plus log base 3 of 9. And that does equal 2 because log base 3 of 1 is 0. Log of any base of 1 is always 0. And log base 3 of 9 is 2 because 3 squared is 9. So that's okay. Alright, so again, the key is you want to make sure you're always checking your solutions to these log equations. Similar pretty much to the rule when you solve the radical equations. Some of those radical equations you had to plug back in to make sure you're not getting the radical of a negative number when you solve it out. Same idea here. We want to make sure we're not taking the log of a negative number when we solve it out. I guess the one lone difference is you're also not allowed to have log of 0 in there, whereas you could do the radical, the square root of 0, and that was okay. Alright, so that's it for solving log equations. I hope you enjoyed the video. Hope you learned something from this. And then I guess I'll see you next time. Meaning Math is out.